We need to start this program by asking ourselves the question, what is virtual reality or VR? Well, VR is a computer technology that allows us to simulate physical presence in a virtual or imaginary environment. Now, this can be achieved by using, at the very least, a head-mounted display or headset, or HMD or HMD, depending on your accent. And as you probably know, there is a very large ecosystem of headsets at the moment from different manufacturers and with different characteristics, and they're not all too compatible with each other. The way a headset works, it is something that you put on your face, on your head, where there is a display for each eye so that you can view these virtual imagery or imaginary computer generated images. And in head-mounted displays, there is, at the very least, the ability for you to look around. That is, the rotation of your head-mounted display is being tracked. In virtual reality, an important concept is that of tracked objects. Basically, the ability to track a certain object, in this case, the head-mounted display or controllers, in space when it comes to its their rotation and their position. So let's take a look at the image on the right here. That image is that video is recorded with head-mounted display that only tracks rotation. So basically, we're always at the same height. If the person jumps in the real world, they're not going to jump in virtual reality. If the person steps forward or backwards or to the sides, in the real world, they are going to stay in the same position in virtual reality. And in this particular case, they are interacting with the world using what's called a reticle, which is like a mouse. Think of it as a mouse cursor of VR. Now, in the image on the left, we see a very different picture. Ignore the controllers for a moment. See how the person there is leaning forward. So if you have that position tracking in your head-mounted display, and you go and you step forward, you will step forward in the virtual world. Same thing if you jump or if you move anywhere. On top of that, in there we have tracked controllers that are being tracked both from a rotation and from a position point of view. And that brings me to another important concept in virtual reality, which is that of degrees of freedom. There are three axes that can describe the rotation of an object. Those come from airplanes. And with those three rotation axes, you can basically describe any rotation in space. And then there are also three axes that can describe the position in space. So if you jump or if you move forward or backwards. So it is common that headsets and also tracked controllers are described in terms of their degrees of freedom, or DOF. So you will see, for example, that the Google Cardboard, where you can only look around, has 3 degrees of freedom because you can only rotate in all directions. But then you have other platforms like the Oculus or the HTC Vive, where there are 6 degrees of freedom for the head-mounted display, because you can have a rotation in all directions, and you can also have position tracking. So you can move forward, you can move backwards. And when it comes to controllers, they also come with different degrees of freedom. And there are some controllers like that of the HTC Vive or the Oculus Touch controllers that have 6 degrees of freedom. They can be tracked in space in all directions. They can rotate and they can move. You can move them up and down, and that will be shown in the virtual world. And there are other controllers, for example, the Samsung Gear VR, at least 2017 edition. It only has rotations. It only has 3 degrees of freedom. You can basically move it around, rotate it around like you would do with a laser pointer. So the type of platform and the type of controllers and the degrees of freedom will really dictate the verbs that your player or your user will be able to carry out in your experience. It's important to think of in terms of verbs when you are designing an experience. For example, in more limited head-mounted displays where you can only look around and click, the main verbs will be around looking at or pointing at or clicking at, whereas with platforms that provide more degrees of freedoms and the ability to have these hand-tracked controllers, you will unlock other types of verbs in your experience. For example, pulling or pushing or throwing or climbing. Those are things that you will be able to do once you have that ability in the virtual reality experience. So that is one of the reasons why the platform that you are going to be targeting at will, in a lot of the time, put either constraints or enable certain things in how you do your experience. Now, something else that I get asked about very often when I mention that I'm doing stuff in VR and AR is what are all these things like? What's the difference between mixed reality and augmented reality and virtual reality and whatnot? So there are many ways of looking at this, and a common one is this reality virtuality continuum. So you have on one end you have reality, the real environment. On the other end you have virtual reality, where everything is imaginary. It is a virtual imaginary world, computer generated world. So this whole spectrum, what's in between, it tends to be called mixed reality, and then you have, for example, augmented reality is when you are looking at the real world, for example, through a camera, and that can be through a head-mounted display or through a phone screen, and on top of this real world footage or view that you get, you have virtual elements added to that. So that could be layers of information or virtual characters or anything really. And then there's something that is not talked about as much, which is augmented virtuality. So what is that exactly? Well, that is basically virtual reality. So it is a computer generated environment, but where the objects that you see, or some of the objects that you see, are actually mapped from the real world around you. For example, if you map the walls of your room in your virtual reality experience, or some elements that are located in your room, like your furniture or something else, that adds elements of augmented virtuality to your experience. So as you can see, this is not as simple, and there are no single definitions here because all of these things are evolving. There are new terms being coined every day, and something I want to mention that will apply to all the stuff that we do with these amazing new technologies is that nothing is here really set in stone. So you can come up with a better way of looking at this same problem. These are all new things. There are no the best practices are evolving as well, so nothing is really set in stone. You can go and question things and you can try something else. So this is not something like a table where if you spend your life, you're probably not going to be able to improve on the table. It's already a perfect technology. These are things that are changing that you can improve upon. So that's all for this lesson. I hope you found this interesting, and I will see you on the next video. Alright, we are going to begin by creating a game design document for our game. Game design documents are documents used in the game development industry, both in small studios and also in larger companies that make AAA games. And their main purpose is to describe in a very short format, usually one page, the main aspects of the game, the concept, and also some of the requirements when it comes to game mechanics and also assets that will be needed. This is a very top level document. It's not an extremely detailed guide, and obviously its extent will depend whether it's a small game or it's a much more complex project. There is not a fixed template on how to create these documents, but in general you want to have something like what I have here. We are going to start by describing the game, the concept of our game, which, as you know, it's a flying platform in VR that moves to different locations in a low poly landscape.
these documents can have text and also drawings and images, or anything that you can use to communicate these requirements to other people or to keep track of them yourself. And you can always update them as you go. So what I'm going to do now is bring up my drawing pad and sketch a little bit of what our game will look like. So we're going to have our player, obviously in virtual reality, and they will be placed in a platform, in a wooden platform that is of a size that's not too big, and it's going to have a handrail. In this manner, they will feel comfortable and safe in this environment. We don't want to make our players feel sick in any experience, and especially not in this very first experience. All right, so this platform will be moving in a three-dimensional low poly environment that's going to have mountains, and there's going to be a big lake and some hills. And in this environment, there are going to be some locations. So I'm going to mark them by drawing some points in here. And the player will be moving very slowly to one location, and then when the player presses a button, it will move to the next location, and then to the next location, and then it's going to go back to the beginning. So the player has control of this process. They can activate the movement, and that takes them to the next location, and they can decide to go further by activating movement again. So it's a very simple experience where they will feel like they're traveling in this platform, and they will have that sense of height, that they're going above a lake and mountains. It is a simple experience, and I think that drawing describes pretty well what it is. So what I'm going to do now is copy this image and bring it into my game design document. And I'm going to place it here. So I'm going to write here as well that this is a very comfortable experience. So there's not going to be much adrenaline happening here. You are obviously free to modify it however you want. Alright, so what platforms are we going to be targeting? This is going to be a cross-platform game. We are going to target mobile VR, in particular Gear VR, Daydream, and Cardboard. And also it's going to be built to desktop as well, but this is going to be what's called a seated experience, because we'll be using the keyboard, we'll be using the space key to activate this movement. And this will include the Oculus Rift and also the HTC Vive or other OpenVR-compatible headsets. All right, that is in regards to the platforms. The game mechanics, as we described, it will be a player moving on a platform, different locations. We are moving in order, so from one to the next, and also there's going to be a single key or single input method, which is going to be the clicker or button on mobile VR and the space bar on desktop. Or it can also be the left click of the mouse. And that's it basically. And we will go back to the beginning. So it's going to be like a circuit. I think I can put that in here. So this is a very simple description for also a very simple VR experience. And when it comes to assets, also the requirements are not going to be very, very complex. So we're only going to need a model for the platform and a model for the terrain. And that's it. So this gives us an idea of what we are building and of what we need. And it's a very simple document, but at the same time it's quite powerful because this really describes what we want to do, and we can easily share this with someone else. And obviously you don't have to use such bad drawings like mine. You can make something better with different tools. This is just what I usually do for my projects, and unfortunately for my team, I also share these sort of drawings with them. So okay, let's go now to just a little bit of an open-ended challenge. So this is something for you to do that I'm obviously not going to be providing a solution for, because I don't know what your idea will be like. But the open challenge is for you to create a game design document of a VR game idea that you have. So that is the first part. And the second part is to try to bring that idea to its simplest possible form, to the simplest type of proof of concept that you could build. And that process will be very helpful, because a lot of the times people have like very complex ideas, and it's great to have a really big vision of what you want to do, but you need to bring that into smaller steps that are easier to achieve. And with game development, it happens that a lot of people have very, very big visions, but they need to achieve the smaller prototypes first. So let's concentrate at this point on getting a proof of concept, a prototype. Okay, let's get started here. I've created a new project, and inside of that project, I went and created a folder called scenes, and I saved my scene inside of that folder. What I want to do now is bring the models from Blender into Unity so that we can set up our basic arrangement, and then we'll start coding the movement of the platform. For that, I'm gonna go here and create a new folder called models. In case you're not familiar with Blender, it's a free open source 3D modeling package that I've used to create the models for this game. Covering Blender is outside of the scope of this course, but I know that many of you are Blender users, so I will show you how I export my models from Blender so that you can do the same thing, and so that process at least is clear if you are a Blender user. So I have Blender open, and I have the two assets that we will import into Unity. One of them is the terrain, and the other one is the platform. So I'm going to begin by exporting the terrain. What I like to do is select my model. So you can press A and make sure it's selected, and then go to File, Export, FBX, which is a file format that is compatible with many other applications. Then you find the folder where you want to export this file. In this case, I've already located the folder models inside of assets. You give this a name. This is going to be called terrain. And in this area here, make sure that selected object is checked, the scale 1, and also this button is it's light like so, it's selected like so. Then export the FBX file. In Unity, if you go into your models folder, you'll see the terrain, and you're also going to see that a folder called materials was created, which contains the materials that were used in this terrain. What I'm going to do now is drag my terrain onto my scene so that we have our nice terrain in there. Okay, now I'm going to do the same thing with the platform. So I'm going to make sure that my platform is selected. I'm going to go to File, Export, FBX, and then I'm gonna give this a name. It's going to be called platform, and I make sure that it's selected object, that this thing here is selected as well, scale 1. I don't touch any of the options in here. I'm going to export that. You can see that I have both in the same file, and if you had different elements, it's always good to make them share the same materials, because that will help with performance in Unity. So if you have different elements that use the same material, make sure they're actually the same material in Blender. Okay, so we have our platform, and I'm going to drag my platform in here. We can see that our platform looks very big in comparison to our terrain. Our platform is actually two Unity units of size approximately, or actually exactly. It is almost two Unity units in each side, which means 2 meters. So that basically means that our terrain is a little bit too small. We should give it a bigger scale. So I'm going to scale this to, I think 2 might be enough. Let's see. And I think that is a good amount. So let's get our platform again and bring it up. And now it's obviously not real size. I think that this can be made even a little even bigger, like 3. Yeah, I think that is much better. Okay, so we have our platform now, and I want to talk about how you work in virtual reality with the camera. In a normal 3D game, so let's bring our drawing pad for that. In a normal 3D game, you usually have your camera, and then you have your player that moves around, and that is in a third-person game, so that will work in a similar way in virtual reality, with the only difference that this camera, it's that this is actually you. So wherever you are looking is where the camera is looking. But in a first-person game, it's also the same way. It's as if you have the camera on you as you walk around. And in this case, this is a first-person game. You will be positioned in this platform, surrounded by those rails. But the big difference between normal 3D games and virtual reality games is that in a normal 3D game, you can move the camera, and you can move the transform of the camera. You can move the camera, you can rotate the camera, you can move it up and down, change its transform basically. Whereas in a virtual reality game, the camera only moves when you move. For example, if you move up, then the camera will rotate to that direction. So you can't impose that sort of movement in virtual reality. A golden rule in virtual reality, and at least I haven't run into a situation where this doesn't hold true, is that you never ever modify the camera's transform. So what do you do then if you want to have this platform moving around? What you do is that you put your camera, this is meant to be the camera, you put your camera inside of another game object, and it is that game object that you can move around. So you can move a parent object, and that is the approach that we will be taking in our game. Now, why exactly, you might wonder, is it that we cannot, or that we should not modify the camera's transform from during our gameplay directly? And the reason for that is very simple. Your HMD, your head-mounted display, will pass on to Unity the rotation according to where you're looking at. So if you're looking up or you're looking down, that involves a rotation in the camera, and that is being passed. So if you try to set that at the same time, you are going to be causing a trouble here, because you're going to set a value, but then the head-mounted display keeps on passing on its rotation based on the tracked rotation. So that is why you shouldn't do it. And what about position? Well, if your head-mounted display has position tracking, and you have, say, a 1 meter by 1 meter kind of area where you can move, it is that positioning there that is also going to be passed by your head-mounted display. So your head-mounted display might also be passing a position and a rotation. Those are reasons why you don't want to, and you should not modify those values. So those are technical reasons, because if you try to do it, the value that you enter is going to be immediately replaced by the current value of the HMD. But then also from a comfort perspective, I'm going to give you an example. Imagine that in real life, instead of you being able to look around wherever you want, there was some sort of hand that comes from the sky and that just rotates your head. That would obviously feel horrible, and you would feel very disoriented and sick, and you would not enjoy that experience. So there's also a very strong comfort argument why that is something that should not be done. If in case it could be done, in case you could somehow disable, and you could disable the SDK connection, the connection between the SDK and the camera, but that would make absolute no sense. Whereas the concept that we're going to be using, which is to put the camera inside of another object, makes a lot of sense even from a real world perspective. Every time that you get into a car, what you're doing is exactly that. You are positioning your own camera, your own person, inside of another object that can move, that can rotate, and it doesn't feel, it feels okay, obviously, except if you start spinning. But that is the main argument here, and that is the analogy with the real world. If you get into a car or an elevator or any kind of vehicle, an airplane, you are getting into another game object that is moving, but you are not being moved by other forces. You're not being rotated. Your head is not being forced by an external hand that tells you where to look at. So those are the main arguments why we are going to have this approach in our game. So let's go back to Unity and let's create an empty game object, which I'm going to call player. And inside of that game object, I'm going to place my camera so that we know that we can now move our camera. We also want to move our platform at the same time that we move this player, because that is how we are going to move in this world. So I'm also going to put my platform inside of this player object. And I'm going to set the coordinates of this platform to be 0, and the coordinates of the camera to be 0 as well, so that everything starts at the same position. And by the way, when I say don't modify the transform, that is during the gameplay, but obviously before the gameplay you do have to position your camera somewhere. Although the rotation is something that you can't control because the player is the one that's going to be rotating, but you can control our original position, although that will also depend on different headsets. There might be some differences there that will be covered when the particular headset is covered later on. Okay, so let's have this arrangement, and let's think that our camera shouldn't be ground level as it's shown here on the game preview. So I'm going to drag the game here. It should actually be somewhere at a normal height of a person, and that again will depend on the headset, because on the HTC Vive the camera is the height is also given by the height of the player, but that is not the case in the other headset. So let's go with this approach, and then if we need to modify something for a particular headset, we'll do it when the time comes. Okay, so we have now something going, and then you are able to move this parent object, and that is how we are going to be moving in this virtual world. What we are going to do next is start our script so that we can move towards a target. I'm going to go here and create my first target. Create empty, and let's call this target. And position this somewhere. It's an empty object. The only thing it has is a transform. It doesn't have any renderer, so it doesn't appear on the game. But it is what we will use to position the targets of this virtual tour of our platform. So we want to move here first. That will be the very first point in our tour. Okay. For that movement, we will create a C# script. So I'm going to go to Assets, and I'm going to create a folder for my scripts. And inside of that folder, I'm going to create a script which is going to be called Player Controller or Platform Controller. So let's open that in our code editor. So I'm going to be using Visual Studio. And there are a few things here that we will be needing. One of them is to be able to pass on that target. And that target will be a position. It will be a vector 3. So we're going to have a public vector 3, which is going to be called target. So this will be the movement target. Something else that we want to have specified as a parameter is the speed of our platform. And that will be a float. I'm going to set a default value of 1. Then there is we will be updating the position of this platform in our update method, which is executed on each frame. When we will be moving until we reach that position. And one way to do that is to calculate the distance between our current location and that ending position, and see if that distance is greater than 0. If the distance is greater than 0, it means we haven't reached there yet, so we should keep on moving. So I'm going to write it first and then implement it. We want to calculate the distance from our target. And also we want to check if we have arrived. So have we arrived? And if the answer is no, then what we want to do is calculate how much we need to move. So this is what I'm going to call the step. And then we need to move by that step. Okay, so let's put this in a variable, the distance. And an easy way to calculate the distance between 2 points is by using a method that comes in the vector3 class called distance. So I'm going to go to help, I'm going to go to the Unity API reference, and I'm going to show you that method called distance. So if we scroll down, we'll find that distance here, and that will return the distance between 2 different points. So that can be easily calculated by using algebra and geometry, and this method does it for us. So let's use that, let's make use of that and type vector3.distance. The position of our position is transform.position, and the other position in space is going to be our target. Cool. So we have the distance. Now, have we arrived? Have we arrived? We can know that by checking if the distance is greater than 0. So if that is true, it means that no, unfortunately, we have not arrived yet. So if we have not arrived yet, then how much do we need to move? And from physics, from school physics, you might recall that the speed is equal to distance divided by time. So we know the speed because we are setting that value, and we can know the time in between update calls by using the delta time property. So that gives us the answer for our step, which is will be equal to the speed times the time that has passed. So by using that, the distance will be equal to the speed times the time, we are going to define our step, and we are going to get that by multiplying speed times time dot delta time. So that is the time that has passed since the last time that update was called. All right. Then how are we going to move to that position? Well, an easy way to do it is by setting the position to we can use again vector3, and there is a method here that's quite useful, which is called move towards. So I'm gonna find it in here in the documentation. We have move towards, and what this vector does, it moves a current point in a straight line towards a target point, and you can give it how much you want to move. So we can tell it move from the current position to the target by this distance that we are telling it to move. So if we type here move towards, and the current position is transform.position, the target destination is target, and the step that we need to move is step. We've just calculated that. Okay, so now we can go to Unity and see if this works with the elements that we have in here. So the very first step will be to drag our script onto our player. And now if you go to your player, you will see that there is the platform controller here. And actually, when you have vector3 as a parameter, it brings you x, y, z, which are the properties of vector3. And what we actually want is to be able to pass on our object. So for that, we need to set that as a transform instead. So what I'm going to do here is set this as a transform, because all Unity game objects have a transform component. So that transform will give us access to the position. So now, instead of using target like that, we need to type target.position and do the same thing here. Okay, so let's go back to Unity and click on player, and you will see now that you have that target that you can drag an object in there, a transform object. So our target, the only thing it has is a transform, so it is definitely something we can use. So I'm gonna drag my target onto that target location, and now I'm gonna press play just to see what happens. And effectively, we are now moving to that direction. Before we go into the challenge, I actually want to refactor our code a little bit and prepare you for the challenge that is about to come. So all of this code here has to do with movement, and we still need to add the user input. So I'm going to be creating a new method here, which will take care of the movement. So I'm going to call this handle movement, and I'm gonna grab all this code and I'm gonna put it in handle movement so that we can have all the code that has to do with movement in one place. And then we will be calling that from here. So this is going to move our platform. Above movement, we will also check for input. And we're gonna call this method handle input. Visual Studio will complain that it doesn't exist, but I'm going to press Ctrl dot and be lazy and have Visual Studio create that method for me. So we have that method there, and it will be up to you to complete the contents of that method. And so how is this going to work? We are going to have a private variable here that is going to be a flag that sets whether we are moving or not. This is going to be a Boolean value, and it's going to be called isMoving. And it's going to start as false. So we're no longer going to start moving. And the way that this input method will work is that it will detect the user input, and according to that user input, it will change this property here to either true or false. And according to the value of this property here, we might or might not be moving in this part of our code. So let's go to the challenge. The challenge will consist on implementing this handle input method. That in there you have to detect whether the fire1 input axis has been activated. So a quick explanation about that. If you go to edit in your project, and if you go to project settings, input, you will see all the input axes, and there is an input axis which is the fire1, which is in the keyboard. It is left control or the right click of the mouse. So we're going to be using that one, fire1. So you have to check if fire1 has been activated. And if that is the case, swap the value of isMoving, so from true to false or from false to true, and then go to handle movement and move only if isMoving is true. So have a try at this challenge, see how far I hope you can do it, but if not, that is okay. I'll be here and I will show you the solution. So pause the video and try this challenge. All right, welcome back. So let's go and solve this challenge. We want to detect whether that button has, that input axis has been activated. So inside of our code, inside of handle input, we are going to check whether the input axis has been activated. And so we're going to check for the fire1 axis. And one way of doing that, there are different ways of doing that, is going to be using input.getButtonDown. So if you're not sure of what method to use, you can always go to the Unity documentation and find all of the methods that exist for that corresponding class. So input class is the one that has to do with user input, and that gives us getButtonDown. And because we're using an axis, there's a very flexible approach so that different devices can be tracked to a certain axis. So in this case, it's fire1. Even that gives players more control, because there might be a new device in the future that you don't know that's coming yet, and that might also use this fire1 axis. Whereas if you use specific keys or mouse events, those things might become obsolete. So that was the first part. It was just detecting if that is pressed. And if that is pressed, we want to basically negate the value isMoving. Negating means, so we're going to negate isMoving. It means setting it from true to false or from false to true. And an easy way of doing that is by simply setting it to its opposite by using the exclamation mark. So that will turn isMoving into its opposite. The third part of the challenge is to modify handled movement and only move if isMoving is true. So we're going to go into handled movement, and only if moving is true, we're going to continue, which means that if we are not moving, exit, basically by checking that. If there are different ways of doing that, you can also make the check outside of the method, but I'll do it here. So you can check that if isMoving is false, basically, we're just going to return. We're going to exit this method. And now if you go to our game and see if this works, let's have a play. Let's have a go here. So I'm not moving at the beginning, and that is what we intended. I'm going to press the right click, and we are starting moving And now if I press that again, we stop and we can resume our movement. So we've solved the challenge, and now we're ready to move on to the next lecture, where we will be adding multiple stop points. Basically, you can have a whole circuit around your landscape. So I will see you then. Before we can implement multiple destinations in our game, we will be covering a programming concept that is very important, and that is the concept of arrays. An array is a data structure that allows you to store multiple values of a certain data type in an ordered way. So each value has an order inside of the array. So look at this array here. What we say at the beginning is, we do at the beginning set the data type of the elements that will be stored in our array. In this case, this will be strings. We used the square brackets like so to indicate that this will be an array. And then this is a way to instantiate our array and set values for the array right away. So we're setting 4 elements in this array. And an important concept when it comes to arrays is that of indices. So each element in your array has a corresponding index, and counting starts from 0. The first element of your array is element 0, and it goes all the way to the length of the array minus 1. So for example, this array has 4 elements, so this will be index 0, 1, 2, and 3. So the last element is always positioned at the length of the array minus 1. So in this example here, we're again declaring and instantiating an array, and in the next line of code, we are accessing one of the elements of this array. We are creating a new variable of type string, calling it favAnimal, like favorite animal, and we can access any element from our array by using the square brackets and indicating the index, the position of our element. Another important concept is that of modification of array elements, how you can modify an array element, and that occurs in the same way than with variables. You simply assign the value, so you refer to the element that you want, in this case the one that is in position 2, so we start with 0, 1, 2, the dog, and we change the value of that position of that element to whale. So the new array will be turtle, bird, whale, cat. Now, some more important things about arrays. You can actually declare an array without specifying the size of the elements right away. So you can just declare, and then you need to instantiate it, and that is when you specify the value, the number of elements that it will have. In this example here, we are actually instantiating the array, but without setting the actual values. All we're saying is we are going to create an array of game objects called players, and we are just saying that there will be 10 elements, but we're not setting them yet. You can do it later. An easy way to get the length of the array is simply to access the name of the array .length, access the length property, and that will give you the length of the array. Now, a few things to keep in mind. Once you instantiate an array, the length of this array cannot be changed later. Also, so if for some reason you needed an array that has a variable length that you will be adding and removing elements, you shouldn't be using arrays. You should be using a C# class called list that will allow you to do that. All the arrays that we've shown so far are what's called static array. For example, these all have their values hard-coded. The values are in the code and the numbers are in the code as well. They are explicitly set. But you can also have dynamic arrays where the number of elements and also the values of the elements themselves can come from methods or from other classes. And that means that the user could be entering a number of elements and then you create the array for that number of elements. But just like I said before, once the array has been instantiated, you can no longer change the number of elements of that array. You can change the values themselves, but you can't change the number of elements. Okay, how are we going to implement this into Unity, and how exactly is this going to work? Let me do a little sketch. Basically, we are going to have an initial position, and that is where our platform is going to start. And then we are going to have more positions, and all of these positions will be game objects in an array. So we're going to have a game object array that is going to be called destinations or targets or something like that. And the way it's going to work is that you're going to start in the initial position, and then when you press the fire button, the platform is going to move all the way to the next destination, and it's going to stop at that point. Then if you press the button again, you can go to the next point, you can look around, check out the mountains or the lake, and when you're ready, you press the button, go to the next one, and when you are on the very last one, you are going to go back to the original one, and there you go. So it's a bit of a circuit, and we are going to be using arrays in this way. So let's move on to Unity and open our code in Visual Studio, our platform controller. We are going to create our array of destinations. So this is going to be destinations or targets, and it can be an array of game objects called targets or destinations. And before we were using a transform for our targets, I think actually a transform is a better alternative than game object, because we're only going to be using the location of those elements, but it doesn't really matter. It doesn't really make any difference. Let's just keep it transform, similar to what we were doing before. And we can also delete this, but if I delete it, I'm going to have a series of errors in Unity because we are using that target here. So I will just leave that now so that I can show you what happens when I create a public array, what happens in the editor. So I've created this public array and it's called targets. So now go to the Unity editor and I can show you what will appear. So let me select my player, and if we go here now, we have these targets. And the first thing that we can enter is the size of our array. This will allow the array to be instantiated with a certain length, of course. So what if I just set a length of, say, 4? What happens then? I get my 4 elements here that I can drag elements in here. We had our first target in this position, and I'm going to start by dragging that target in here. So that is our first position. Then what I'm going to do is duplicate by pressing Ctrl D and placing the other one, let's say somewhere here up in this mountain. Then I want to have another one that it's more, let's have the top view. It is more somewhere here, and then another one that is more in this part, and then another one that is just a bit further. So I think we have a bit of a circuit here. What I'm going to do is put them all into one single game object. So I'm going to call these targets, and I'm going to drag them all into here. And now let's add them to our player. We actually have 5 targets to add, not 4. So I'm going to change the size to 5, and there we go. So we have our first target is there. Then the second one needs to be dragged into this position, and I'm gonna be doing the same with all of them, so that they're all so that we can access them all from our code. The very first I want to do is that when the game starts, I want my platform to begin in target 1. That is the initial position of the platform. So in our start method, in our code, in our start method, we are going to set that as the initial position. So if we go to start, we're going to set the player to the first target. This means that transform.position equals the first target, and if you recall from our arrays diagrams, the position at the beginning is position 0. So we are going to type in here targets position 0 dot position. So now if we play our game, you can see that even though the player is positioned in this part, and that is where position 0 is, when the game starts, we begin in that position. That is going to be our first position. That's going to be the beginning of the circuit. All right, so let's continue and make this travel across the different points. We can now get rid of this target here, and we want to keep track of which our next destination is. So when you start the game, your next destination, if we start in 0, the next destination should be 1, because that is the first place that we're going to be moving towards. We're going to create a private variable for that, which is going to be called next destination index. It's going to be an integer next index, and since we are starting in 0, then initially the next destination is it should be 1. And let's do it like that. So index. And if you want, instead of having hard code the numbers like this, you could also have that as a parameter, and then you could just say that you could have a variable called initial index, and this would be initial index. You can set it to 0 or any other number, and then you can also just say the next index is going to be that number plus 1. And you'll have to check if you are at the end of the array, you have to then set it to 0. Okay, but this will do. So our next index is where we're moving towards. And inside of handle movement, we saw that if we are not moving, we obviously don't call this. But if we are moving, we check that we haven't arrived yet. But what if we have arrived? That is an else here. If we have arrived, we should update the next index. So else, and that means if we have arrived, else our next index will be increased by 1. And also we want to set the fact the is moving to false, so that we stop moving. So let's go to Unity and see if this works. Okay, so we have an error here, and it says here the name target does not exist in the current context. And that makes sense. So what we can do here is replace this by targets in position, in the position next index. So targets in position next index, because that is the direction that we're moving towards. So we replace that in both places. And now save and go back to Unity and press play. So we can see that we start here, and if we click, we are moving to the second location. And I can go, and actually I want to increase the speed just to make it really fast so we can easily see how this is working. So what if I click again? Then we go to the next target, and if we go again, we go to the next target, and if we go again, you go to the next target. But you will see what happens now. We get an error, and it says here array index is out of range, and that is what you will be solving in the next challenge. So challenge time. Each time that we reach a destination, so when we arrive to a destination, check that if we have arrived to the end of our array. And if that is the case, as you saw, we're gonna get an error. So in that case, next index or the index of the target should go back to 0. It shouldn't keep on increasing. So that is going to be your challenge, is to make this work so that we can actually go and start over our circuit. All right, so you had a try and hopefully solved the challenge. And what I'm going to do now is just show you the steps on how this could be solved. And with all of these challenges, sometimes you might have to do a little bit of research to solve them. And also there's not always a single way of solving a problem. There are multiple ways of implementing all of the things that I'm doing. So if you did it in a different way, that is fine. Okay, so when we increase our index, we want to make sure that we are still in the array. And an easy way to do that is to use this array length property that I showed you before. So we can check, and if the next index has actually arrived to the length of the array, if we have arrived to that point, it means that that object no longer exists, because array objects, I'm going to write it here, array elements, the index, array element index starts at 0 for the first position and goes all the way to the length -1. For example, if the array has 3 elements, it will go from 0 to 2, which means that if you increase it and we reach the length of the array, that means that we should be, we're outside of the array. There's not going to be an element in there by definition. So next index in that case should be set to 0. And if we go to our game and we have another play, let me set the speed to something really fast so that we can quickly check if this works. We go there, 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 and we're back. So we are able to do this whole round trip. There you go. We've got this working, and now it's time to move on to the next lesson. In order for us to build games for any of the VR platforms out there that are based on Android, there are a few things we need to do. And what we'll do in this lecture is cover those things so that you can go through that process and then move on to the lectures that correspond to the platform or platforms that you will be targeting. Google Cardboard, Google Daydream, Gear VR are all based on Android, and the steps I will cover in this lesson will take us towards the point where we can start actually testing the games in our phones. A quick overview of the process. We need to make sure that Android build support is in our Unity install. Also, we're going to be installing the Java SDK and the Android SDK and a bunch of Android packages. There's going to be a lot of downloading, so I hope that you have a good internet connection and a good hard drive, because these things are quite heavy. And we're going to end up by setting up our phone for development and enable USB debugging, which is something that you need so that your computer can speak to your phone via USB cable and send games to it, so you can test your games on your phone. When you downloaded Unity, I'm hoping that you checked the option Android build support, but if you didn't, that's fine. You can always run the download assistant again, or download it again from the download Unity again, and then just make sure that you install the Android build support, because that needs to be part of Unity for you to move any further. In Unity, we're going to go to Edit, Preferences, and then External Tools, and you will see an area that says Android, and it has a few fields that we are interested in. We're only interested in the first 2 fields, which are the location of your Android SDK and your Java SDK. In order to get this, we're going to start with looking at the Java one. You just click on the download button, and that will take you to the Oracle website, where you can download the Java Platform JDK that corresponds to your operating system. So you can download from there, and it will take you to a page with a lot of options so that you can pick the one that corresponds to your operating system. So I'm using Windows here, but by no means this is only related to Windows. This applies to also Mac and Linux as well. So you can download the one that corresponds to your system and just install it, and take note of in which folder it was installed. You can just go with the default folder and write it down or copy it, or change it to a different folder, but you need to be able to find that folder later. So you've installed your Java SDK, and then you enter your the location of the folder here. You go to Browse, and then you will find that location in your computer. So now let's talk about the Android SDK, to which, by the way, we will be taken to if we click on the download button here. So in the past, you could just install only the Android SDK, which was a bunch of command line tools that also came with a user interface that allowed you to download the different packages and to create emulators and to do a few things. So it was basically a mixture of command line tools and also a user interface, and that was great. But things have changed a little bit, and these days, if you download just the SDK, which you can do if you scroll all the way down on this page, you're not going to get any of the user interface tools. And I find it that to manage to download the packages on Android, or to manage my Android SDK, I do prefer to have a user interface. So unless you're already an advanced Android developer, I would definitely not recommend to download just the SDK. So what I've done here is download the whole Android Studio suite, which is a very heavy, very comprehensive program, but it's the only way for us to get those UI tools, and that is why I've downloaded that option. So once you click there, you will see different install instructions according to your operating system, and you'll find obviously the most up-to-date install instructions in there with a video as well. So you will download this, and you need to make sure to select the Android SDK, of course. And also what's very important is the location of your Android SDK. As you can see, you will be able to set the location of your Android Studio, which you probably won't be using much unless you're into Android app development, and the location of your Android SDK. So that is the location that we will then have to find in Unity. So keep that in mind. And don't copy the same values that I have, because I've set up custom locations for my packages. So that will take a while to install and download. And then in Unity, you need to then make sure to enter both your Android SDK location. In my case, I've put it on a different drive because I don't have more space in the C drive. And or I don't remember what the reason was why I chose that one, but basically, it's up to you to install it wherever you want in your own computer. But just make sure that you enter the folder that corresponds to your computer, not to copy the ones that I have in here. All right, so you enter both the Android SDK and the Java SDK. But there are a few things we need to do with Android Studio. So go and open Android Studio, and then you might have to download the latest SDK from there. You'll be prompted. And just make sure that you are choosing your location of the Android SDK. So there might be a little bit more of downloading here. Then you'll finally be able to open Android Studio. But we're not done yet with it. On this home screen, go to Configure and go to SDK Manager. The SDK Manager used to come as a standalone tool with the Android SDK files, but now it comes with Android Studio. That is the reason why we install Android Studio. So in this part, go to Android SDK, and make sure again to have the right location of your Android SDK. And in the listing of SDK platforms, those are all the versions of Android that you have to select. What I mean is that you have to pick the versions of Android that you want to target. So for example, in this case, I've selected Android 6.0 and Android 7.1.1. My phone is using Marshmallow. That is why I've selected that option. So that's also what I would recommend here, but then again, it's up to you to which versions you're targeting with your own games and applications, or which is going to be your main target. The fact that I pick a Marshmallow doesn't mean that the game is not going to run with other options, but that is just my main building target. And now we can finally move to our phone. So the first thing you need to do is enable developer tools on your phone. Activate developer tools. And if you go to settings, you by default are not going to see developer tools. Google has like a funny way of unlocking this. It depends on your Android model and your version. So you'll have to Google for your own particular phone model and how to activate developer tools. In my case, I think I had to go to the About Android page in the settings and then tap some number 10 times and it would appear. So it's different on each phone. Then once you have that active, go to settings, developer options, which will now appear, and make sure that that's on, and also make sure that USB debugging is on, because that's very important. Then what you'll do is connect your device to the computer. And in here, there might be some issues depending on the operating system and the phone. In best case scenario, you will just see on your phone the option to allow USB debugging, and then you have to accept that. And obviously, if you're going to be using that computer for development, I would always allow that computer to have access. So I would check on that box, but that's just my preference. In Windows, you might be prompted to install some drivers. And if that happens, go with it. So do install whatever they need you to install, because sometimes the phone needs a particular driver to run. And this is something that I've run into in the past. If your computer is not able to recognize your phone, you can always just go to that URL and find the drivers for your particular brand. And there's also a link with more information on when you set up your device. One way to check that the device is connected by USB for development is to run a command line called ADB devices. The ADB command, the ADB tool comes with the Android SDK. And to be able to run this on the Mac, I've provided a link that explains, but the process is basically to add the path of this command to a file that's called bash_profile, .file_profile. And in the command line in the Mac, if you open a terminal, what you can type is the command that's there, which means that we are adding a certain path to the path variable. And this part here that says .android SDK Mac OS, that needs to be replaced by, this whole part needs to be replaced by the path where you've installed your Android SDK. The sign means that it's in your home folder. So replace this by the location, and then inside of your Android SDK, the location is platform tools. And what we're doing here, we're just saying that everything that is in platform tools, we can just call it from the command line. So after doing that, and after reloading your bash profile file, which is explained in this link, if you type ADB devices, you will be seeing your Android device. On Windows, if you just go to any folder in your terminal and you type ADB devices, you're gonna have this message that says that ADB is not recognized as an internal or external command. What you have to do is actually add the location of a couple of folders in the location of the Android SDK for a lot of these Android commands to work fine. And for that, you have to go to this computer or this PC and go to Properties, and then go to Advanced System Settings, Advanced Environmental Variables, and then you will see a list of environmental variables and find the one that says Path. So click on that one, click on Edit, and then you need to add the folders that I'm showing you in the slide, and you can download as well from the course material. So those two folders, Tools and Platform Tools, contain a lot of these Android command line tools that people use when doing Android development. In this case, the ADB command is what will allow us to see if the device is actually connected. So once you've done that, and you just type ADB devices, and then you will see that device. It will show like a long string of numbers and letters. That is the unique identifier of your device. So you will see it in there. And if you've seen it in there, it means that you are good to go. So you are connected to your computer with your phone, and your phone is ready for development. So an open-ended challenge for you is basically to set up everything as described in this lesson and get your device ready and listed in ADB devices. So basically you are ready to continue and to be able to run Unity games on your Android phone, and after that you can move on to the platform or platforms that you're actually going to be working with, the Google Cardboard or Daydream or Gear VR. Google Cardboard is a mobile VR platform developed by Google that consists of a head-mounted display and a smartphone. This platform was launched in 2014 and it is the low-cost alternative for people who want to try virtual reality. What's unique about Cardboard is that the specifications for the headset are public, and anyone from companies to individuals can build their own. In fact, Google only started selling their own headsets in 2016. And you can find Cardboard viewers on eBay starting at $5. The headset itself is extremely simple. It's made of cardboard or plastic. It has 45mm focal lenses and a magnet so that you can activate input on your screen, usually with like a trigger button. And sometimes they have straps or Velcro to adjust it to your head, but not always. As VR game developers, we need to understand how this platform works and how it differs from some of the other mobile VR platforms and desktop platforms as well. When it comes to Google Cardboard, the best way to look at it, or an easy way to look at it, is to think of binoculars. That is mainly the role it has. It's mainly like an optic role, because you put your phone there and the lenses will do the job to present the image for each eye to you, so that it gives you that sense of 3D. But there is no hardware level integration, and so as I said, it's mainly optical, plus obviously that magnet that can trigger an input event on the screen. In virtual reality experiences, the sensor that is in charge of measuring where you're looking at in the game, basically the angle of your headset, of your head, and its acceleration, is called an IMU, which is an inertia measurement unit. And when it comes to the Google Cardboard, you are relying entirely on your phone's IMU. So if you have a phone that is VR ready, that has a very low latency IMU, this means that the time from when the measurement is taken to when this measurement is delivered to the software is very little. So the measurement occurs in a very short period of time. Then you're going to have a great experience with Cardboard. But what is more, the most common case is that phones are not going to provide, don't necessarily come with a good IMU. And so the Cardboard experience in many phones can be actually quite laggy, can have a bit of a lag. When you move your head around, there might be a little bit of a delay, or the movement might not feel very smooth. So this is something very important to keep in mind. Also, phones themselves don't really know about the Cardboard. When you put a Cardboard headset on, the phone doesn't know that you are on Google Cardboard there, and also phones don't come with deep kernel level integrations for this platform. And one of these optimizations that is present in the Gear VR and on Google Daydream is reprojection, which is that when you have your frames per second of your game, when that drops a little bit, in these other platforms, the previous frame that was shown will be reprojected again, so that the frame rate doesn't drop, and people usually never notice that, so the experience will feel a lot more smooth. Whereas with Google Cardboard, that feature is not present, so the games might feel a little bit jagged as well, especially if there's a lot of processing taking place. And something else that's important to mention is that in Google Cardboard, but this is also in other mobile VR headsets, there is no head position tracking. So all that's being tracked is your head rotation, that is where you're looking at. But if the easiest way to see it is that if you jump on VR, or if you jump in reality, you're not going to jump on the VR game, which is something that would happen if you're using a headset that has head position tracking. Now, because of all of these things, I don't want to give the impression that I don't like Cardboard, that I'm against it in any way. I think Cardboard has played a very important role in bringing VR to a lot of people. It's broadly used in schools in developing countries, and my main point here is that as VR game developers, we want to know where the limitations are of each platform, and also manage expectations, just so that you know what to expect, because great VR experiences can be built for Cardboard, but you need to be aware of some of its limitations. And something that I'm really hoping for is that as new phones become more and more VR ready, I hope that their IMUs also become low latency and that they are prepared for the cardboard experience more than they are now. When it comes to developing for cardboard, what just seemed to be a weakness, which was that there's no hardware integration, it is a strength when it comes to multi-platform support, because even though this is created by Google, Cardboard works both on Android and iOS, because as long as an app follows the specifications when it comes to showing both the camera for both eyes and whatnot, it can be used on Cardboard because it is mainly an open specification. And in Unity, since version 5.6, there is native support for Google Cardboard, both for Android and iOS, so you don't have to install any SDK in order to develop apps for Cardboard. Now, back in Unity and back in our game, we are going to build our game for Google Cardboard for Android. So I have my game here, and what I'm gonna do, also I have my phone connected, and I'm able to see my phone when I go to a terminal and I type ATV devices. I can see my phone attached in there. So what I'm going to do now is go to File and Build Settings. And in here, I make sure that my scene is there, but although there's only one scene in this game, so even if it's not there, it will be built as by default. So pick the Android target here and click on Switch Platform, because it's going to be in there by default. And then we're going to go to Player Settings in this button here. And this will contain all of the settings for your player, the player, and by the player I mean the what is going to run the app on your phone. So you can set a few fields there, like company name, name for the project, things like the icon. But what we are interested in is we're gonna scroll down and go to Other Settings. And inside of Other Settings, we're gonna pick Virtual Reality Supported. So we're gonna make sure that that is selected. And in here is where you can add the virtual reality platform that you're going to target. So let me remove this and show you how you can add it. So if it's like this, list is empty, you can go here and click on plus, and you're going to see all the platforms that are supported by default by Unity. So I'm gonna pick Cardboard. So I pick Cardboard, and then you need to scroll down a bit, and in identification, you have to write what's called a package name, and this is what's called a reverse URL. It's just a unique identifier, which is usually something like your website, but written in the opposite way. In this case, com.zenva. If you don't have a website, you can just make one up here. This doesn't really matter. It's just a convention. And then you type like dot and the name of the project, something without spaces. So in this case, it can be VR flying, something like that. And in here, in minimum API target, I am selecting the phone. In this case, I'm using Samsung Galaxy S6 Edge Plus, which has Android Marshmallow. That is the phone that I'm gonna be targeting here. So after I selected those options, if I go back here, I have the option of to just build the game, or to build and also run the game. So what I'm gonna do is build and run, because then we'll get prompt to save our build somewhere, and then it's actually gonna run on the phone that is connected. So I'm gonna click on build and run, and the first thing that will happen is that you have to select a destination for your APK file. The APK file is the file that will run on your Android. This is usually the file format for Android apps. Inside of my Unity project, I'm gonna create a new folder, which I'm gonna call builds. You can call it however you want. Builds, I think, is a good name just because it really explains what it is. So we're gonna save all of our builds here, and then you can give this file any name you want. It's not gonna make any difference if you're gonna be building, making different builds for different platforms and whatnot. You can use a naming convention like Cardboard build. I'll leave that up to you. So I'm just gonna call my game, and I'm gonna click on save. And now we are gonna have this process, which could take a few minutes, especially if it's the first time that you're running this. That usually takes longer. And again, in case I didn't mention it, I have my device connected via USB, because like I show you here, I can see it. So my phone is ready for development. And what this will do, it will build that package, and then it will install it on my phone and run the application on my phone. So the process completed. It took a couple of minutes, And now I can see my app from my phone. So I'm going to show you that now from the phone itself. Okay, so we are now on our phone on Google Cardboard and we are in this VR experience. So you can look around and you can see that that we are in this experience now, and I'm gonna start moving so the input works fine. And I can look around and that's it. So now what I would like you to do is to make maybe some changes to the game, a couple of changes, and then to run it yourself so that you can test it. And there are optimizations that we can do, so that is covered at the end of the course. We'll do a little bit of optimization here, but optimizations will definitely improve this a little bit. I do feel like it's I do feel that it's laggy. I don't know if that is captured in the video, and a little bit jagged, but part of that has to do with my phone in particular, that my phone doesn't provide an amazing cardboard experience. So that, again, we are relying on the phone for the rendering of this game and the phone capabilities. But all in all, it is a VR experience, and I'm happy to be in this virtual world. So, all right, so let's continue. The Gear VR is a mobile headset manufactured by Samsung and developed in collaboration with Oculus, the Facebook-owned company behind the Oculus Rift headset. The Gear VR headset only works with selected Samsung phones of the Samsung Galaxy family. You connect the phone using a USB-C or micro USB port, and the headset itself has a touchpad on the side and a button to go home and to go back. And since 2017, there is also a controller added here. The headset itself has two sensors. One of them is a proximity sensor that activates when you put it on, and the other one is an IMU or inertia measurement unit, of which I'm going to speak about very shortly. How the headset works, it tracks 3 degrees of freedom, and this is only rotation. Basically, if you have the headset on, if you are on a VR experience, and if you jump on real life, you are not going to jump on VR. So that is what this means. Only rotation is tracked. You can see 110 degrees, that is your field of view. And just so that you have an idea, the humans see 180 degrees. The controller itself is the rotation of the controller is also tracked, so that is also 3 degrees of freedom. There's no position tracking for the controller either. So think of it as a laser pointer that you are holding with your hand at a fixed distance from your body, and that you just rotate around. So that is one way to look at it. When it comes to rendering, and this is very important for us game developers, is that the headset itself, as I mentioned, comes with a sensor, which is an IMU. IMU stands for Inertia Measurement Unit, and it is a sensor that contains gyroscopes and accelerometers. It is a sensor that can measure this rotation. Basically, the sensor will tell our software what direction we are looking at in virtual reality. And the fact that the headset comes with its own IMU, and that IMU has low latency, which means that we get the measurement right away or in a very short time, it means that experiences can feel quite smooth. And if you look around in your game, it shouldn't feel like chopped or kind of laggy, which can happen, for example, with Google Cardboard, which relies on your phone's IMU. So if your phone doesn't have a good IMU, the experience can be a bit jagged in that platform. There is also a kernel level integration, and the phones that are ready for Gear VR come with a lot of optimizations, and a very important one is reprojection, which means that if the frame rate of your game drops for some reason, for example, there's too many things happening, the previous frame will be shown so that the frame rate stays the same. This is the number of frames per second, so that it keeps at 60 is the target in Gear VR, so that it keeps at that number, and the experience still feels smooth, and most people won't notice that the same frame was presented, but it will definitely feel smoother than when this optimization is not present. When it comes to developing for Unity, we are very lucky because Unity natively supports the Gear VR, building apps for the Gear VR. The only thing that at the time of this recording is not natively supported is getting the rotation of the controller. And for that, you would need to use the Oculus SDK. But everything else, and it is supported natively, so nothing is required for you to build games for this platform. Now let's go to Unity and let's build our game for the Gear VR. But before I can do that, before I can build my game for the Gear VR, we need to download what's called a signature file from the Oculus website. So let's go to the Oculus website. Let's go to the developer.oculus.com, and you have to sign up as an Oculus developer. Once you've signed up as an Oculus developer, for which you can use your Facebook account or you can create a new account, you have to go to the dashboard of this Oculus website, so dashboard.oculus.com, and then there will be a link here to go to Tools, and in Tools you need to enter your device ID. And the way to get that, so you need to have your device already configured to be used for development, is to use the adb devices command. So in your terminal, just type adb devices, and that will show you the ID of your phone. So you have to copy that value and paste it here, and then download a file. That is a file that basically authorizes the app to be run on that phone, and that is something you need to do for development. And you can find some more information in this page. Now, where do we have to place that file in our computer? Well, this is the folder of our project. So the way to place it is you have to go to Assets, create a new folder called Plugins. Inside of that Plugins folder, create a new folder called Android. Don't worry about this meta file that is created automatically by Unity, so ignore that. Just create another folder called Android, and then a folder called Assets. The case needs to match the ones you see here. So it is your Assets folder, then Plugins like this with capital P, Android with capital A, and then Assets. And inside Assets, you can place the file that you download from the Oculus website. So without this, you're going to get an authorization error on your phone. You're not going to be able to run the game or the app. Okay, so after we've done that, let's go to Unity. And as you can see, I have my assets here, assets folder, and you can see that the plugins folder is here, and inside the plugin we go Android and Assets, and the file you download, which is unique for your phone. So I'm not going to be providing the file for my phone. So once you have that, you are pretty much good to go. What you need to do is go to File, Build Settings, and in here you need to add the scenes that you're going to build. If you don't add any scene, and there's only one scene in your game, that is added by default. Then that is the scene that's going to be built, but I always like to add them just to really see it explicitly in here. In platform, make sure to pick Android, and then to click Switch Platform, so that you are switched to the Android platform as your main build target. Then click on Player Settings, and in here there are a few fields that we need to complete, which are common for all Android applications. For example, your company name, the name of the game, and you can also add your icon. But what we're interested the most here, if you go to you need to make sure that the Android icon here is selected. Go to Other Settings, so make sure to expand the Other Settings tab, and make sure to click Virtual Reality Supported. So that is something we need to add in here. And then in here, I'm going to remove this so I show you how you can add it. You are able to add the SDK, the platform that you're targeting. In this case, it's the Gear VR, but what I will say here is Oculus, because as I mentioned, the Gear VR is developed in collaboration with Oculus. And then something important as well is the package name. What you enter here is called it is called that reverse URL type of notation. So for example, if you have a website, type like com.your website and then the name of the game, like a short name without spaces. If you don't have a website, that's fine. You can make one up here. This doesn't have it doesn't have to be a real website at all. This is just your unique identifier. So it usually starts with your own unique kind of company or personal name, and then the name of the product itself. Then on the target APIs, in this case, I've selected that the minimum API level is Android Marshmallow. That is the version of my phone at this moment. And I don't think that there are phones that have a lower version than this that actually work with Gear VR. So you need to find that out at the time that you're doing this. But I think Marshmallow is fine. And I'm leaving all the other options untouched in this part. And then we have two options. We can just build the APK file, or we can build and run it on the device. So, and this can take a couple of seconds or a couple of minutes the first time you do it. So what I'm going to do now is run the build and run, just to be sure that it's all working. So I'm going to click that. And again, my phone is connected and it is shown here. So that is all working fine. So I'm prompted with this build file. And for that, I've created a folder called builds in my Unity project, and I'm going to call this game.apk. You can have your own naming convention. You can call it however you want, and maybe you want to call it differently for each platform if you're building for many platforms, or you want to have some sort of numbering system. So that's up to you. I'm just calling it game, and I'm going to replace the one that's already there. All right, so now the process begins. Okay, so I have the application now open on my phone, and it tells me to insert my device to my Gear VR. So that is what I'm going to do now. And this is loading in the Gear VR, and it says here that it requires my permission to access photos, media, and files on my device. I'm going to allow that. And it requires all these permissions that just came by default. So there we go. VR. All right, so we are now able to run our game on the Gear VR. I'm using the Gear VR's native video recording tool, and which makes this supposedly look clean, so you shouldn't be seeing the double camera. And as you can see, I can look around, and if I press the button, I'm able to activate this elevator and to keep on moving around and whatnot. So there are a few things that we fix here. There's an issue with the shadow that looks like jittering, but other than that, looks great. It feels really smooth when I move around, and that's it for the Gear VR. So let's now continue with the course, and there will be a couple of things that we still need to do in our game. Google Cardboard is a mobile VR platform developed by Google that consists of a head-mounted display and a smartphone. This platform was launched in 2014, and it is the low-cost alternative for people who want to try virtual reality. What's unique about Cardboard is that the specifications for the headset are public, and anyone from companies to individuals can build their own. In fact, Google only started selling their own headsets in 2016. You can find Cardboard viewers on eBay starting at $5. The headset itself is extremely simple. It's made of cardboard or plastic. It has 45mm focal lenses and a magnet so that you can activate input on your screen, usually with like a trigger button. And sometimes they have straps or Velcro to adjust it to your head, but not always. As VR game developers, we need to understand how this platform works and how it differs from some of the other mobile VR platforms and desktop platforms as well. When it comes to Google Cardboard, the the best way to look at it, or an easy way to look at it, is to think of binoculars. That is mainly the role it has. It's mainly like an optic role, because you put your phone there and the lenses will do the job to present the image for each eye to you, so that it gives you that sense of 3D. But there is no hardware level integration, and so as I said, it's mainly optical, plus obviously that magnet that can trigger an input event on the screen. In virtual reality experiences, the sensor that is in charge of measuring where you're looking at in the game, basically the angle of your headset, of your head, and its acceleration, is called an IMU, which is an inertia measurement unit. And when it comes to the Google Cardboard, you are relying entirely on your phone's IMU. So if you have a phone that is VR ready, that has a very low latency IMU, this means that the time from when the measurement is taken to when this measurement is delivered to the software is very little. So the measurement occurs in a very short period of time. Then you're going to have a great experience with Cardboard. But what is more, the most common case is that phones are not going to provide, don't necessarily come with a good IMU. And so the Cardboard experience in many phones can be actually quite laggy. It can have a bit of a lag. When you move your head around, there might be a little bit of a delay, or the movement might not feel very smooth. So this is something very important to keep in mind. Also, phones themselves don't really know about the Cardboard. When you put a Cardboard headset on, the phone doesn't know that you are on Google Cardboard there, and also phones don't come with deep kernel level integrations for this platform. And one of these optimizations that is present in the Gear VR and on Google Daydream is reprojection, which is that when you have your frames per second of your game, when that drops a little bit, in these other platforms, the previous frame that was shown will be reprojected again, so that the frame rate doesn't drop, and people usually never notice that, so the experience will feel a lot more smooth. Whereas with Google Cardboard, that feature is not present, so the games might feel a little bit jagged as well, especially if there's a lot of processing taking place. And something else that's important to mention is that in Google Cardboard, but this is also in other mobile VR headsets, there is no head position tracking. So all that's being tracked is your head rotation, that is where you're looking at. But if the easiest way to see it is that if you jump on VR, or if you jump in reality, you're not going to jump on the VR game, which is something that would happen if you're using a headset that has head position tracking. Now, because of all of these things, I don't want to give the impression that I don't like Cardboard, that I'm against it in any way. I think Cardboard has played a very important role in bringing VR to a lot of people. It's broadly used in schools in developing countries, and my main point here is that as VR game developers, we want to know where the limitations are of each platform, and also manage expectations, just so that you know what to expect, because great VR experiences can be built for Cardboard, but you need to be aware of some of its limitations. And something that I'm really hoping for is that as new phones become more and more VR ready, I hope that their IMUs also become low latency, and that they are prepared for the Cardboard experience more than they are now. When it comes to developing for Cardboard, what just seemed to be a weakness, which was that there's no hardware integration, it is a strength when it comes to multi-platform support, because even though this is created by Google, Cardboard works both on Android and iOS, because as long as an app follows the specifications when it comes to showing both the camera for both eyes and whatnot, it can be used on Cardboard, because it is mainly an open specification. And in Unity, since version 5.6, there is native support for Google Cardboard, both for Android and iOS, so you don't have to install any SDK in order to develop apps for Cardboard. Okay, so how we actually build the game for iOS. We will need a Mac computer, and when we install Unity, we need to have selected the iOS build support option. So if you didn't select this during the installation, you can always run the installation again and make sure that this component is included. A quick overview of the process. We will have installed Unity with iOS build support. Then in our Mac computer, we need to have the latest version of Xcode installed. We need to have an Apple ID and add that in Xcode. And then we will build the project from Unity. And what building from Unity does, it really creates an Xcode workspace, and then you need to access that workspace, and from there you can run it directly on your device. So now let's go to my Mac computer and let's build our game and run our game on Google Cardboard on iOS. In your Mac computer, you have to download Xcode from the App Store. So download and install Xcode. Now in Unity, we're going to open our project, and I'm just getting a message because I saved this project in my Windows computer, and now I'm opening it on my Mac computer. I can see my project. Okay, so what I need to do now is set the build settings to iOS and Cardboard. So I'm going to go to File, Build Settings, and make sure to select iOS in here. So I'm going to select iOS, and also I need to make sure that my scenes are added in here, for which you can use Add Open Scenes. So I've selected iOS, and then I'm going to click on Switch Platform, which makes the iOS platform the default one that we are using. I'm going to go now to Player Settings, and I see now all of these settings on the side. And in here, I'm going to scroll down all the way to Other Settings, and I'm going to click Virtual Reality Supported. And in here, you will see a list. And in this list, I need to add the Cardboard target. So I'm going to click on that plus button and pick Cardboard. The other thing that you need to enter that is quite important is the bundle identifier. So in here you enter a unique string, which usually has a reverse URL or reverse DNS format. So it's sort of like a URL address, but the other way around. So you usually start by typing if you have a website, you type your website, but if you don't have one, you can just create your own sort of personal brand or company brand, and then dot and a unique name for this project. Let's say that this project will be VR platform or flying game, anything you want. Okay, so this is important. And now that we've done that, we can build our project. And what this building process will do, it will create an Xcode project for us. The location is going to be, we are inside of our Unity project. I'm going to create a new folder here, which I'm going to call builds. And inside that build folder, I'm going to, I have to enter a name for the folder of for the name of my Xcode project. I'm going to call my Xcode project VR flying. And I'm going to press save. Okay, so the process completed, and what I have now is inside of my builds folder, I have this VR flying folder, which is my Xcode project. So I'm going to click on that, and inside of this list, I have to find the file that corresponds to my Xcode project, which is this one, the one with extension .xcodeproj. So I'm going to double click on that, and that will open the file on Xcode. Now, if this is the first time that you use Xcode, set your Apple ID in Xcode. For that, what you can do is go to Xcode, Preferences, and then add your Apple ID in here. So you press the plus button and you add your Apple ID. In this case, I have already done that because there are other previous projects in my Xcode program. Okay, so we are now on the Xcode project for my Unity game, and you can see a few things here. For example, in signing, I have to, it says here, signing for a Unity phone requires a development team. So I have to pick my development team here, and you should be seeing here your own account, or you might add it, you can add it from add account. So I'm adding that in here, and it is creating a few things for me. What I can do now, I can see here, for example, that the bundle identifier is not the one that I had entered. So for some reason that didn't get saved, or that or I need to enter it here again. So I need to make sure that this is a valid bundle identifier. We are now ready to build and run our app on our phone. But before we do that, I want to show you a couple of changes that I made on Unity. So if we go to Unity, what I did was in here in the player settings, I set the target device to iPhone only, because you can't really run, or I guess there's no point in running a cardboard app on an iPad, because that was the other option, was iPhone plus iPad. So I set it to iPhone only, and this was on iOS 7, and I've set it as 8 as the minimum version. We are already in iOS almost 11, so there's clearly not much of an interest to target older versions of iOS. So I've done those two things, and then I went and I clicked build, and I kept the same name that I had entered before, and I was asked whether I wanted to modify the previous project or whether I wanted to replace it entirely. And I went and I just replaced it entirely, just because I also wanted to make sure that my bundle identifier was correct. So back on Xcode, I basically had to pick the signing team again, and now everything looks fine. So we are good to go. What you need to do then is unlock your phone and connect your phone via USB. So I'm doing that. The phone needs to be unlocked, that's very important, otherwise it's not going to work. So you can see my phone here, and this is because I've already used this phone in the past for development, but when you connect a new phone, you will be prompted to use that phone for development, and there's also going to be this automatic signing taking place. So my phone is now ready, and to build and run the game on the phone, all you need to do is just press play here. So that might take a minute or so, and then you will be able to run the Google Cardboard game or app on your iPhone. All right, to finish here, I wanted to show you how now the app runs on the iPhone. So we have our game on Cardboard on iPhone, and I tried it on a Cardboard viewer that is a little bit too big for this phone, and to be honest, this is a bit of an older iPhone, and the result was a little bit laggy, a little bit jagged, but that is because we are relying entirely on the IMU of this phone. So the big hope is that newer phones will come with super low latency, amazing IMUs, so that this experience can actually be a lot better. The Oculus Rift is one of the main VR headsets for the desktop computer. It came out originally as a Kickstarter campaign that showed the world for the first time that consumer VR could be a viable option, and as new prototypes were created and eventually the consumer version came out, it really opened up a world of virtual reality experiences and games that hadn't been seen before, and it's pretty much inspired a lot of the growth of this whole area over the last few years. The Oculus has different input methods. When the Oculus itself comes with an Xbox One controller and with like a clicker, which is called Oculus Remote, and you can also get tracked controllers called Oculus Touch. And the store where Oculus games are published is the Oculus Store, but you can also run games on the Steam store with your Oculus Rift. The way that the Oculus works, the headset itself has 6 degrees of freedom. This includes 3 rotation axes and 2 position axes. For the rotation tracking, the way this works is the headset itself has a low latency IMU. IMU stands for Inertia Measurement Unit, and it is the main sensor that is used in virtual reality to detect where you're looking at. It consists of accelerometers, and gyroscopes, so that it can accurately measure what your orientation is. And for position tracking, it uses a very clever system called the constellation system, which I'm going to explain in a little bit. The Oculus Touch controllers also have the same 6 degrees of freedom and work just like the headset when it comes to the constellation system. The Oculus Rift has 110 degrees as a field of view, horizontal field of view. Just for your reference, humans see 180 degrees. And when it comes to the constellation system, I would like to show you a bit of a diagram on how it works. So if you have your computer and you are seated in your computer and you have this Oculus Rift thing on, you will have seen that the Oculus comes with a sensor that is something like this. So this sensor is actually an infrared optical sensor that is looking, and the way that it tracks your object, in this case your headset, is the tracked objects have LEDs that blink on a certain pattern that the sensor obviously knows, and that allows the sensor to track the position of the object at a sub-millimeter level. If you get the Oculus Touch controllers, that works in the exact same way. So these controllers will also have a LED that is detected by the sensor. But now what happens now that we have 2 objects, what happens if you move and for some reason your headset is blocking the way to the sensor, to the controller, so that the sensor cannot see the controller? The controller has been occluded by the sensor. Well, that is why the Oculus Touch controllers come with a second sensor that you have to place in a different position, and so that then you have the possibility of still detecting these objects, and you remove this problem of occlusion. I'm not entirely sure if it's entirely removed, because there might be a situation where still somehow something is being blocked, but it definitely reduces or diminishes this problem. So that is how the constellation system works, which you might have read about when you got the device, or if you've been researching about it. Now, developing for the Rift in Unity, which is what really matters to us as we're going to be making all these games. Unity has a native integration with the Oculus Rift, and that includes the headset and the controller. So that is really good news. You don't have to install anything to be able to run a game on your Oculus Rift, which is something that used to be different in the past. The Oculus website does have a few additional tools and plugins, if you will. There is one for spatial audio and also for avatars, and there might be other things as well at the time that you look at it. And in here, there's something that it's important to mention. So like I said before, games that you develop for the Oculus can go on the Oculus store, and they can also go on Steam. But there's this is the thing. So if you build your game for the Oculus SDK in Unity, you'll be able to publish it on the Oculus store, and also you'll be able to use some of these third-party tools that I was mentioning if that's what you want to do. But if you can also build your game in Unity by selecting OpenVR as a target. And OpenVR is an open standard, an API that was developed by Valve, and that what it does, it allows VR games to run in the Steam VR runtime. So it is made for Steam basically, and you can also integrate deeply with this API. But if you do that, then you can no longer publish your game on the Oculus store. So it's pretty much like you have to, what I would recommend is basically to stick to native Unity features for as far as you can. Things like the camera. Nowadays, you don't need to have a different camera for each one because the Unity camera supports the different SDKs and so on. So you need to go as far as you can with Unity's native features, and then eventually you'll have to go one way or the other, or both ways, in which case there are a few solutions out there. Like some people just have developed their own custom pipelines to work around this issue. But I want you to know that this is not a solved problem these days at the time of this recording, and that there's not like a single easy way to have that cross-platform support that we get in other areas these days. So keep that in mind. And what we're gonna do now is go to Unity and run our game in Oculus. But before we do that, the requirement is that I'm assuming that you have Oculus already installed and running in your computer, that just like you would to play games. So you have Oculus installed, you're able to play games on your Oculus, you have everything set up when it comes to the headset and whatnot. So once you have all of that in place and your device is connected, now we are going to go to Unity and run our game on the Oculus Rift. Okay, I'm in Unity, and what we are going to do now is go to File, Build Settings. We are going to make sure that PC is selected here, so switch platforms in case you had another platform selected. Then I'm going to go and press on Player Settings, which will bring this area here that has a lot of options. And what I'm going to be doing here is go down all the way to Other Settings and find the option that says Virtual Reality Supported. So that's going to be unchecked by default. So I'm going to make sure that that is checked. And then in here, if you can see the Oculus platform, but if that is not appearing, you can always just go and press the plus sign and add Oculus. And that's it. So I can, before we build the game, let me just show you what happens in play mode. And by the way, if you connected the Oculus while you had Unity open, you might have to close Unity and open it again. Sometimes I find it that it doesn't recognize it right away, and that's how I solve it. So I've got virtual reality supported. We are on the Oculus platform. And what I'm going to do now is simply press play. And as you can see, I am on virtual reality now. So I can look around, and I'm going to press the button on the Oculus remote, so that little clicker thing. I can also just use the mouse and press the left button to activate the movement. So we are moving, and everything looks super smooth, super high quality, and that's it basically. So another thing I wanted to show you was how the transform of the camera changes. So I'm gonna disable this maximization here. Let's press play again. And what I'm going to do is click on the camera, main camera. Before the game begins, the height of the camera was set to this number, 1.52. And when the game starts, if I place the Oculus at the height that I entered on the Oculus setup, so when you set up the Oculus, you would have entered some height. The camera position will change according to that height that I set originally. So as you can see, if I move up, if I'm moving the Oculus up, the position goes up. If I'm moving it down, it goes down. And again, you can easily see what position tracking is like. Basically, if I jump in real world, you will jump in VR. And I can also move forward or move backward, move down, besides just rotation, which is what you would have on some of the other platforms that we looked at. All right, so that is the Oculus target platform. And when it comes to building, what you can do is go to File, and then you can go to Build Settings, and you can either do Build, in case you will just save the executable file, or Build and Run. So I'm gonna Build and Run, and I'm gonna be prompted with this option. Where do I want to save my executable file? So I've created a folder called Builds, and I'm gonna enter here, I'm gonna type game-oculus. I'm gonna save that. The building process might take a little bit, and once that completes, the game will be run. Okay, so the building process completed, and this is just like building a normal desktop game. So I'm getting these options when it comes to the resolution, and I'm just gonna go and press play, and we now have the game on the Oculus Rift, and I can move around and just experience it similar to what I did before. But usually when you build, the quality is a little bit better than when you're running it on the editor. So that's it for the Oculus Target. Now, what if I want to use my Oculus with the OpenVR SDK instead of the Oculus SDK, which is what we just did? In that case, the first thing you need to do is download the Steam store in your computer. Create an account if you don't have one. And once you've installed the Steam store, you have to open it and go into your library and select Tools. And in the list of tools, you have to find the one that's called Steam VR. So this is the runtime that is used to run virtual reality games which use the OpenVR API. So you have to install Steam VR. And then in Unity, you have to change the build target. So go to File, Build Settings. In PC, Mac, Linux standalone, go to Player Settings and scroll down to Virtual Reality. In this case, I had the Oculus as the target. So you can add this and sort of place it before the other one. But I can also just remove the Oculus one. So it is now set as OpenVR. Then I'm gonna close this, and when I press play mode, the Steam VR tool is going to be opened, and you might get errors like this, like the headset is not being tracked and whatnot. So you can see it now, but I want to show you the setup as well for the Oculus Rift. So you do have this. You have to run the same room setup that you would have run on Oculus, but it's just a little bit different. Okay, here we go. We are going to set up this room as standing only, and then you need to set the tracker on a location that's visible to the sensor. So I have that. I'm doing that, and this is important. So you want to set up where your personal forward direction is, where you are going to be looking at. So in this case, I am pointing the headset towards the screen, and I press Calibrate the Center. And this part is very important. You saw that when we were using the Oculus SDK, that we started at a height that was set by how much we were moving from the original position, right? So if you had set up, say, 1.50 meters and you didn't move, you would stay on the position that was originally set up on Unity. Whereas here, the height that we enter, this works differently than the Oculus SDK. The height that we enter here will be added to the existing camera's position. So because we have already set a height of 1.5 in the camera, in the player, I'm going to set this at 0 so that we don't add anything on top of that. If we set our actual height in here, that will be added on top of the other number. So what you would want to do if you are going to be developing for Steam VR, you want to make sure that the camera in the player, that the camera is at position 0. And then you can enter your actual height in here. But I'm not going to do that, as I said, because we have already set up a height of 150 in the player. So I'm going to calibrate the floor. And now go to next. And we are done. So now if I go to play mode, this works exactly like what we had with the Oculus SDK. But we are now on OpenVR. And if we go and check our camera, the camera is in a position very, very near that height that we defined originally. And that is what we wanted. So I'm going to repeat this part. So if you know that you are going to be developing for Steam VR, you want to make sure that this value is 0 at the beginning, so that then you can enter your actual height and have the camera move all the way up to that height. And maybe if you're going to develop from more than one platform, as I said, that is not an easy thing to do. You might have to have an if statement and check which platform you're in, and according to that, set the position to 0 for Steam VR and for a fixed number for a different platform. So that's it for this lesson. I hope that you guys got the game working. And I just want to give you a quick introduction to what it is like to develop with the Oculus and what the main options are for you these days. Something I forgot to mention regarding OpenVR is that the Oculus the Oculus Remote, that clicker, doesn't work in OpenVR. So if you are on OpenVR, to move in here, you need to use the left button of the mouse. The HTC Vive is a hugely popular head-mounted display manufactured by HTC and developed in collaboration with Valve, the company behind the Steam game portal. When you create games for the HTC Vive, you can sell them on the Steam store, and if you make non-games, apps of different kinds in virtual reality, there is also the Vive board store. And how does this platform work, basically? The different tracked elements, which includes the head-mounted display, the controllers, and also optionally additional tracking volumes, they have 6 degrees of freedom, and this means 3 rotation axes are measured and also 3 position axes. Basically, the objects can be tracked in space and it can be tracked what their orientation is. For the rotation tracking, they use low latency IMUs, that means inertia measurement units, which are sensors that consist of gyroscopes and accelerometers and are used in virtual reality to measure rotation and know where the orientation of the headset or the controller is. When it comes to position, the system that is used to track is called the lighthouse, which I'm going to explain in a second. The head-mounted display has a field of view of 110 degrees, which means a horizontal angle of 110 degrees. Just so you know, we humans see 180 degrees. So now let's take a look at this lighthouse system. So imagine that you have your computer and you have your lighthouses, which are these black boxes that are placed in different positions of the room. And then you have your head-mounted display and maybe one of the controllers and the other controller. So the way the system works, the lighthouses are sending infrared light across the room. And the different tracked volumes have sensors that can detect these signals, and that allows them to know their position, and that position is then given to the software so that you are positioned in the right place in your virtual reality game. This works similar to a real lighthouse, because if you have a real lighthouse that can be used by a boat in this case to have an idea of where it is located. So that is where the name, that is why it is called like that, because it works really in the exact same way. Now, for us developers, some things we need to know. Games for the HTC Vive are the way that this is built into the device is using an API called OpenVR, which is an open source API created by Valve that allows any manufacturer to use it in order to have a standard when it comes to developing for virtual reality. Now, the runtime where these applications are executed is called SteamVR, which is a program that is part of the Steam software that you download and install. So from that point of view, it is indeed an open API, but at the same time, it is linked to the Steam ecosystem. You can actually check out the code of this library on that link, and also there is a discussion for the group for developers where they solve issues about this API. And just so you know, this it's changing very often at the moment. There is a lot of new things coming out just because of how new virtual reality is in general. So a lot of the things, it's good to keep an eye on the changes that occur when you are developing games for this platform. When it comes to Unity, the head-mounted display is actually supported natively, so you don't need to install anything in order to have both the position and rotation tracking of your head-mounted display working in Unity. That works out of the box. When it comes to controllers and the track volumes, at least at the time of this recording, you have to install a plugin Unity via the Unity Asset Store. It's called SteamVR, and then you have to use the SteamVR API to access this volume. So we're not going to look at that in this lesson. And you need, of course, to have Steam and SteamVR installed in your computer. What's great about this is that there are multiple headsets out there that are supporting OpenVR, and you can use any of them with the same system. Even the Oculus Rift is compatible with OpenVR, so you can also develop for the Oculus Rift using OpenVR. Okay, so now let's go into Unity and let's have, I'll show you what the setup is about, and then we're gonna run our game for this platform. Okay, let's look at the different steps that we need to do in order to run our game in Unity. You need to download and install, and for that you need to create an account as well, Steam, which is an online store for video games. So you've downloaded Steam and you've installed Steam in your computer. It runs in all platforms. And then inside of your Steam application, go to Library, then Tools, and in the list of tools, find SteamVR and install that from here. SteamVR is a runtime where games that use the OpenVR API run. So basically all the games that you build with OpenVR need to have SteamVR as a runtime. That is how they are run on your device. So we've installed SteamVR, and now I want to show you a few things in Unity. So in Unity, when you are working with OpenVR, the position of your camera should ideally be set in here to 0, because the height of your headset is going to be added to this position here. So if what you would do, for example, in mobile VR is that you would set a certain height here, for example 1.5. That's a very short person, but still you would set a certain height that is expected for a person, that will give the person the kind of perspective that they would have. However, when working with OpenVR, you start on 0 and then the height of your headset is going to be added. So you are going to end up with your actual height in the game. So that is something to consider. I'm going to set then this to 0. Before we can actually run the game, we need to make sure that our room is set up correctly. What we're doing in this video is look at the standing experience. We're not using the controllers here. And when you're not using the controllers, you don't need to install anything additional in Unity. Everything will work natively in Unity. If you were to use the controllers, you have to install the SteamVR Unity plugin from the Unity Asset Store, but we're not covering that now. Okay, so let me show you how this room setup works. So you have to run SteamVR, and in SteamVR, you go to run your room setup, and in here we're going to select standing only, and then you need to make sure that your headset is within the tracking area, and then you need to make your headset point towards the screen and calibrate that center like so. And after that, this is where we configure the floor. And like I said, the actual height of the device is going to be added to the game. So in this case, all I have to do is just place my headset in the floor in some area that is tracked, and I'll leave this to 0 so that we are setting the floor. So we are setting the floor here. That worked fine, and we are done with our setup. Okay, now we can build our game. So I'm gonna go to File, Build Settings, and I'm gonna make sure that PC, Mac, Linux standalone is selected. I'm going to switch platforms in case that wasn't selected. You have to make sure that your scene is here, the scenes of your game are here, and then go to Player Settings. In Player Settings, you can enter the company name, the name of your game, a few other fields like the icon. But what I want to show you is I'm going to scroll down and go to Other Settings. And in Other Settings, I'm going to make sure that virtual reality supported is checked. So it's going to be like that by default. I'm going to make sure that that is checked. And then there might not be anything in there. So let's clear that list. The list is empty. And I go to plus, and then I go to select OpenVR. Okay, so we have that selected. Cool. Let me close this for now. And now I'm going to press play. And just like so, we have our, I'm using the HTC Vive here, and I can stand up, and I'm located in my platform in my virtual reality game. And if I use the left button click, it needs to be clicked on the game screen. I start moving. So let me make this a little bit bigger, so you can look around, and it all looks really good quality, really sharp. That is when you run it from the editor. And if we go to our camera, I can show you how the height of the camera is being set by the height at which I have it right now, which I'm seated with the headset on my head. So if I move it up, it goes up. If I move it down, it moves down. And one thing is that for some reason, if say you move the lighthouses, and then all of a sudden you are in a position, say x equal 2, so you're off the central area when you're developing, and a really quick way when you're developing to recenter the position, basically to set it at 0, so that your current position is 0. Let me show you how that can be done. So I'm positioned at a certain height, a certain x, certain z, and if I want to force myself to be in 0, so to sort of reset the position, I can go to SteamVR, and I can go to Settings, and then in Settings you can go to Developer, and then go to find here, scroll down, Quick Calibrate, and that forces the camera, it centers it to be in 0 again. Obviously you can then still move because you're still being tracked, but see how this actually made us be under the area. So for some reason the headset is not tracking right now. I probably shouldn't have done that while playing the game. So I think that kind of broke it. Like let's try again. Yeah, so here we go. See how we're now like kind of at the ground level because I did that reset. And the only way to get the other position back will be to run the room setup again. Okay, the other thing I wanted to show you was how we can build the game. So you can go to build settings and you can pick build here or build and run. So let's go and build and run. And what we build here is just the executable. So I've created a folder called builds inside of my game project. And in here, I already built it for the Oculus and I can build it now for the HTC Vive. You can call this however you want. I just called it like that to differentiate the two of them. And then we have this building process that can take a few minutes. And our game is built. So this is just like running a normal Unity game. So it's just loading, and I have that game that I just built, obviously with the position reset. So I should run my room setup again to get the right position. And actually, in the real game, the quality is always better than the quality in the Unity editor. Just so you know, sometimes in the editor you see artifacts which are like kind of like stains on some of the colors and some of the surfaces, and this looks a lot more clean, a lot sharper. So I'm going to close this now. And that is how this process works. So as you can see, this is supported natively by Unity, which is great. And at the time of this recording, the controllers are not supported natively, so you have to download the SteamVR SDK plugin into your Unity project. And yeah, so we got this working, and now let's continue with the course.